Okay, so let's go over quickly how to make a Photovore robot. First of all, quickly, what is a Photovore? Well, photo is like light, photons, and vor is like carnivore or herbivore, to eat. So this is a robot that eats light. You got it. And so this means that the robot is always looking for a source of light to eat, presumably. Meaning this is a robot that's looking around. If you put this robot in a dark room and you put on a flashlight or something, it should go towards and find the flashlight. Or if you're using this robot in a room with a bright window, it should ideally find its way to that bright window. Okay, so that's what a photovore is. And so on my screen right now, what do you see? You see the robot, which is plugged in and on and already connected to Snap. Okay, but very importantly, I have the light sensor connected to the GPIO. So A0 here, which is the GPIO pin that can read the light sensor. It's the only black pin of all the GPIOs. It's a special one. And so that's A0 there. And this is the light sensor over here, this little round and red thing. And A0 is connected to LS here up top, which LS is for light sensor. You got it. So we have A0 connected to LS, very important. And that will activate the light sensor. And A0 is special because every other GPIO pin can just read 1 or 0, digital, on or off. But A0 can read a whole gradient of things between 0 and 1024. So it can tell, for example, if there is more light or less light in a certain direction, not just 1 or 0, but we actually get a number back from this, which you'll see as I go ahead in the example. Anyway, I tucked the robot in a CAN eBrain in the front of the robot, making sure to face it forward, because we need the light sensor to be able to see which side has the most light. Excellent. So let's go over to Snap here. I've already loaded up the Photovore code, but let's just take a look at what it does. So first things first, we'll look at the when green flag clicked. Let's start with that, okay? So first it connects to the eBrain wirelessly, okay? Then it makes this variable called light. But it makes the variable a list, which means this variable actually has 3 variables inside it, which it starts off as 0, 0, 0. So let's run that, and we can see we have the variable light with 3 tiny variables inside it, a list, each one being 0. Cool, so that's how it begins. Then the first thing it's going to do in a forever loop, it's going to broadcast check left, center, right. So and wait. So it's going to wait for that to be done before it moves on to the next. So what is check center left right? Well, we can go up here. I divided it up so it's a separate little piece of code. And this piece of code does a sweep. So we're turning first left 45 degrees. So imagine you're facing forward and you turn left 45 degrees and take a light reading. So let's take a look at that running. We'll do it in steps. Bloop. So you can see the robot has just turned left 45 degrees and taken its first light reading, which is 416. So to the left of the robot, the light is 416. Now let's do the center. So we're going to turn right 45 degrees. Now the robot is back at the center, and from the center we can see that there is more light, 465 in this direction, which makes sense. I believe this is going to be the biggest one because the window is right in front of the robot. So I believe facing forward, the robot will get the most light. So that's towards the center. There's 465. Now let's turn to the right 45 degrees. And we get our last reading, which is 438, which, like I said, is not quite as much as the middle, which is 465, which is where the window is. So that's what this code does. It quickly does a sweep, going left, center, and then right, and taking down the light values with using the analog read block. We're recording the light value into this list. So the first one is left, second one is center, third one is to the right. Okay, So after it does the sweep, it checks which is the biggest number. So it's very obvious to us that the biggest number is here, 465 in position 2. But that's what this piece of code does. Okay, let's take a look at this piece of code. We run it, and sure enough, we come back with the value 2. The position of the biggest number is in position 2. So it just runs for I to length of light. Length of light is 1, 2, 3. So it runs and loops 3 times using I as a counter. So I will first be equal to 1, then to 2, then to 3. This is a counter. It's a little bit tricky to understand, but basically this is like a repeat loop that's looping 3 times, and I is the position it currently is in, the interval that it is currently on. So first it checks item number 1 of light, which is 416. So it says, is 416 greater than item position of biggest number of light, which in this case is 1. So it's checking, is 416 bigger than 416? We'll go with yes, and it'll set the position of the biggest number to 1. Okay, good. Now, is item number 2 of light, 465, greater than item number 1 of light? So is 465 greater than 416? The answer is yes. So now it sets the position of the biggest number to 2, right? And then finally, it does the next one. Is item number 3, 438, bigger than item number 2 of the light? So is 438 bigger than 465? No, it's not. So it doesn't change the position of the biggest number, which stays at 2, which is the biggest one. So this basically just checks all 3 of the positions, and this saves the position of the biggest number into this variable, position of biggest number. Okay, great. And then it comes back here. If the biggest number is the one in the first position, then, as we can see on our robot, it's currently facing to the right. So then turn left 90 degrees. So go all the way left, and then go forward 200 millimeters. If the second one is the biggest position, then turn left just 45 degrees facing center, and then go forward 200 millimeters. Or finally, if right is the biggest one, turn right, which it already is right, so it doesn't have to turn, it just has to go forward, right? Because if you look at the robot on my screen now, it's already facing to the right. So let's run this code, and this code should get the robot to turn towards the center, since the center is the biggest number, 465, and then go forward. And sure enough, the robot turns towards the center and goes forward towards the window. So if we did this in a loop, right, the robot would start to look for the window. So let's just take a quick look at that. Okay, so I'm putting the robot here where it is not facing the window. Excuse my camera work. And then I will run the code. So it does its sweep first, and then goes and faces the window and starts to go forward 200 millimeters. And then it's going to do the sweep again and check which way does it get the most light, and that also is towards the center. So it's making its way to the window where I have a big truck outside. Anyway, so that is the Photovore robot, and it's working. It's going towards the window. Enjoy.